Okay, since we're into something new, I thought I would go ahead and put my mug up here in the corner for a minute. All right, now what we're doing now is we're going into the pre-lab phase, and this will be all I'm going to do today to get you set up for the pre-lab phase. Because what's going to happen on September 2nd, the pre-lab is due, and on September 9th, the actual lab is due. Okay, so we've got, and I know Labor Day weekend's thrown in, but it's not that hard of a lab. However, I do want you to gather data on 30 individuals dropping a ruler. So far, you have no idea what the lab is. So let's go into that. Let's go and look at see what are we talking about. Uh, um, we're talking about free fall. Okay, that is what we're talking about. We are talking about free fall. Okay, so I think I need to go back to the all the stuff you'll need part here real quick, and let's call up the free fall slides. What do we mean by free fall? When something is in free fall, let's take a peek at this. Sorry, I should have had this ready to go before. Any day. Come on now. Come to Papa. All right. When an object is free fall, has a constant acceleration in the absence of air resistance due to Earth's gravity. So it's accelerating at 9.8 meters per second squared. This acceleration is directed downward. Those of you who've never taken physics before might be going, what the heck is an acceleration, and what does he mean by it's going downward, and all of that kind of stuff. Here's what we mean by this. All right. So if we, I'm going to show you right now. As soon as my ladybug opens up, as soon as she turns on over here, turn on over here. Here we go. And then you're going to see an equation that might blow your mind if you're not used to sciencey stuff, but that's okay. But what do we mean by a free fall? Free fall. Okay, so these are our pre-lab notes. We're going to replace last year's pre-lab notes because I like to do the free fall. This is free fall. This means we're accelerating downward at 9.8 meters per second squared. So we'd put a negative sign in front of. What does that mean? For every second something falls, so it starts off 0. Is it speed before at the start? We say v naught like that at start. And then after 1 second, here's the time. After 1 second, it'd be falling at 9.8 meters per second. Okay, so here's the time. It's falling in seconds. After 2 seconds, what do you think? Right, 19.6 meters per second. After 3 seconds, how fast? Beats the hell out of me. I can't add. Okay, sorry. It'd be 29.2 meters per second. No, because it would be minus 29.4 meters per second. That's how fast it'd be falling. You might be going, well, how fast is 29 meters per second? Well, let's go up to 4 seconds. And let's just see how fast it'd be going. Because you may not understand meters per second may mean nothing to you. All right. And so we're going to make sure that you kind of get that. So after 4 seconds, so I go 9.8 times 4, 39.2 meters per second. After falling for 4 seconds. Well, how fast is 39.2 meters per second? Here's how we do. Let's get this in miles per hour. I'm just yakking here, okay? Just to kind of show you how this is kind of cool. All right, so here's what we do. We do 39.2 meters per second. What we're going to do is multiply by things that are 1. So I want to get meters up and put miles. So I know that 1 mile is equal to 1,609 meters, ballpark. So my meters units cancel, but this is 1. because it's 1 mile is 1,609 meters. And now I need to get seconds down below, and per hour. Oh yeah, and then I've got 3,600 seconds. I was having a moment there in an hour. Why 30 is equal to 1 hour? Because it's 60 minutes in an hour times 60 seconds in an hour. So I wind up with, times 60 seconds per minute. So the minutes cancel. Left with seconds, 60 times 60. And so if I take 39.2 times 3,600 and divide that by 1609, because that's down below, this will give you your miles per hour. Whoa, 87, almost 88 miles an hour after 4 seconds. After 5 seconds, let's figure out what it is. So 5 times 9.8 is equal to this. And so it's 49. So I'm going to take 49 times 3,600 divided by 1609. Bam! 109 miles an hour. You know where you're reaching? Almost terminal velocity. How long is your reaction time going to be? The time you're probably going to get is probably around 0.18 seconds. So it's not going to fall very far. And it's not going to be going very fast. Okay? This is about between 0.18 and probably 0.4 seconds about your free fall times that you're going to get in your lab. Okay? But this is all about this is all about free fall, which means the pull of gravity and what an acceleration is. Because what an acceleration is, basically what an acceleration is, it's the change in velocity over the change in time. Because if I take 19.6 minus 9.8 and divide it by 2, which is the 2 seconds, I will get, or divide it by the change in time, the 1 second, I'll get 9.8 meters per second squared. So that's what acceleration is. All right, now, I'm going to stop here and we're going to go on to track.